Having understood the basics of great circle, small circle, spherical triangle, as well as the important, very important cosine formula, now we can proceed ahead to solving a basic great circle sailing question. Now, a basic, very simple great circle sailing question involves having given two different positions on the surface of Earth. Two different positions are provided to us, latitudes and longitudes. The coordinates are given, and we need to find out the great circle distance between those two positions. Now, another important thing with the great circle sailing is that when we move along a great circle track, one important characteristic of the great circle track is that the course of the ship, the heading of the ship, keeps on changing continuously. This does not happen with the simpler methods of sailing, or you can say rumbline methods of sailing, that is parallel sailing, plain sailing, or Mercator sailing. In these methods, you steer a single course from your starting position to your destination position. But in great circle sailing, as the vessel proceeds along the great circle track, the course continuously keeps on changing. So in a basic great circle question, they ask us to find out the initial course of the vessel when it starts from its initial position, and the final course of the vessel when it reaches its destination. So the information which is given to us are the initial and final positions, their coordinates, that is latitude and longitude, and the items which we are required to find out is number 1, the great circle distance, and number 2, the initial and final courses. So let us see now how do we obtain these required items using the principles of spherical trigonometry. Now the first thing which we need to do is to make a rough diagram of the area. So for making this rough diagram, I will initially be using the complete Earth in my diagram. You can see the sphere being shown on the right side of the screen. This sphere represents the Earth. Later on, when we are familiar with the method, we do not need to draw the full Earth diagram. We can draw a small part which involves our initial and final position only. But for understanding, let's have the full Earth being shown. So we have the Earth here in our diagram. Let's show the equator also. You can see the equator. In our plot. Now let's plot the initial and final positions as well as the poles in this diagram. You can see the North Pole at the topmost location, and you can also see the South Pole being marked in the diagram. So let's now plot our initial and final positions. These positions are given to us in the question. Let's assume that the initial position of the ship was at this particular location. Let's name it as A. So A is our initial position. Let's mark the final position also. Let's assume that the final position of the ship or the destination is here. Let's name that final position as B. B is the final position or the destination where we want to reach. Now we want to calculate what is the great circle distance between A and B. And when we are moving along this great circle track, What is our initial course when we depart from the starting position, from position A? And what is our final course when we reach our destination position B? Now for this, let us mark the meridian of both these positions. You can see on the screen now, I have marked the meridian of my starting position A on the diagram. So this meridian is passing from the North Pole as well as from the South Pole, and this meridian also passes from my initial position A. So this is my initial position A's meridian. Now this meridian cuts the equator at a particular point. Let's name that point as C. So we have the C point on our plot now. Now let's do the same thing for our final position. You can see the meridian of the final position B plotted in the diagram. This meridian passes from the North Pole, from the South Pole, as well as from my final position B. This meridian cuts the equator at a particular point. Let's name that point as D, delta point. Now, since we want to find out the great circle distance between A and B, let's mark the great circle track from my initial position A to my destination position B. So you can see the great circle track marked in red in the diagram. The arrow shows the direction on which we will be proceeding, moving from point A to point B. So this is the great circle track between our initial and final position. Now, if we concentrate our attention on this part of the diagram, that is AC, alpha to Charlie. Now, alpha to Charlie is the arc of the meridian contained between the equator and position A. This is exactly what the definition of latitude is. The definition of latitude is the arc of the meridian contained between the equator and that particular position. So that is what AC represents. So this tells us that AC is the latitude of our initial position A. Now we also know that from the pole up to the equator, if you measure the distance from the pole up to the equator along any of the meridians, it converts or it comes out to be 90 degrees. So pole to point C is on the equator, will be total 90 degrees. So this arc, Papa to Charlie, is going to be 90 degrees. We have just now seen that AC, alpha to Charlie, is equal to the latitude of the observer, latitude of the initial position. So this tells us that the arc Papa alpha, which is marked in green now in the plot, will be equal to 90 minus latitude of A. This is also known as co-lat of A or complementary latitude of A. So in this question, the latitude and longitude of both the positions are given to us. So calculating 90 minus latitude of A gives us the dimension of the side Papa alpha, that is the green color side of this particular triangle PAB. Okay, now going by the same principle, you see Bravo to delta, B to D is the arc of the meridian contained between the equator and position B. So again, this is the definition of the latitude. So the arc Bravo to delta represents the latitude of my final position B. I also know that pole to D, P to D will be 90 degrees. Pole to the equator along any of the meridians is always 90 degrees. So Papa to delta is 90 degrees. Bravo to delta is equal to the latitude of my final position. That tells me that Papa to Bravo, the blue color side, is going to be 90 minus latitude of B. So you can also call it as the colat of B or 90 minus latitude of B. Both mean the same thing. Now, if you pay your attention to this triangle, which is formed on the Earth, that is Papa, Alpha, Bravo. Now, this particular triangle is formed on the surface of Earth, and all three sides of this triangle are arcs of great circles. Papa Alpha is the arc of the meridian of our initial position A, which is a great circle. Papa Bravo is again the arc of a meridian, which is the meridian of B, which is again a great circle. And the third side of this triangle, the red color side, that is Alpha Bravo A to B, is of course a great circle track. It is the arc of an great circle track. That is what we need to find out. So we have a triangle, Papa Alpha Bravo, PAB triangle, formed on the surface of a sphere, which is the Earth, all three sides of which are arcs of great circles. So this tells us that this Papa Alpha Bravo triangle is a spherical triangle. Okay, so we have a spherical triangle, and in this triangle we have already identified the two items which we know. One is side Papa Alpha, which is colat of A, is known to us as the latitude is available to us in the question. The second side Papa Bravo, which is the colat of B, again available to us as the latitude of B is given to us. Now let's try to see what all other information is available here. Let's concentrate our attention on angle Papa of this triangle. This is highlighted in the diagram now. Now angle Papa is the angle at the pole contained between meridian of A and the meridian of B. So this is the definition of D long or difference of longitude. So this is the D long between A and B. Now, as we know that the position of both these points A and B, initial and final position, is given to us, we have the longitudes of A and B known to us. Once you have the longitudes, we can easily find out what is the D long between A and B. So the D long between A and B gives us angle P of the spherical triangle PAB. So this is the third item which is known to us, that is angle Papa. And if you look carefully now, what is known to us are two sides of this particular triangle and the included angle. Thus, it satisfies the criteria for application of the cosine formula. So I'll be applying the cosine formula on triangle PAB now. Beta, any doubts or queries up to here?
Sir, regarding this figure and going from point A to B, This will also change anti-clockwise and clockwise as a we will be come to know as a shorter distance where we have to go. The shorter distance, it will be either from the other side of the sphere also, right? So this diagram, we have to make it accordingly. I mean, other way also, east and west side also in the quadrant, we have to
Yeah,
show
beta, what
opposite.
okay, what I understand is one which you have said a correct thing, that there is a great circle track which is joining both these positions A and B. Now,
Yes,
when you follow that great circle track, there will be two options. Either you can go eastwards
yes,
or you can go westwards. In both the cases,
yes,
starting from A, you will be able to reach B. So what we are interested is in the shorter arc of that great circle. That's one thing. And
yeah,
secondly, beta, the direction in this particular example which I have taken is easterly direction. Now, if the ship was going from B to A, let us say the vessel has already reached B, done the cargo operation, and now it wants to go back to port A on the reverse passage. Now then in that case, the arrow direction would be towards the west and we will have a westerly direction track. So that is very much possible. It all depends upon the location of our starting and final positions.
okay, so
Okay, beta, understood?
yes, sir. Sir, I mean, when we will draw it in the quadrantal form, we will make a cross and we will put all these directions, and we will uh, draw a triangle, this spherical triangle over there, and the sides will change accordingly. East will come to the west side and west will to the east side, depending upon the shorter distance, how it is going, and
Uh,
that will be
okay,
calculated by
बेटा
d long.
हाँ ओके ओके बेटा अब इसमें मैं कुछ चीज़ आपको बताता हूँ the thing which you said is correct 100% correct the direction of the d long will tell you whether you are going easterly or westerly so जब आप अपने
Yes,
starting position और destination position का d long देखोगे तो डी लॉन्ग की जो
yes,
डायरेक्शन है वो इमीडिएटली आपको बता देगी कि आप ईस्टर्ली डायरेक्शन में जा रहे हो या वेस्टर्ली डायरेक्शन में जा रहे हो दैट्स परफेक्टली राइट 100%। उसी से हमें पता चलेगा कि हमें पीएबी ट्रायंगल को कैसे बनाना है मतलब बी को राइट साइड में
yes,
रखना है ए के या बी को ए के लेफ्ट साइड में रखना है इफ़ यू आर मूविंग ईस्टर्ली दैट मीन्स द डेस्टिनेशन विल ऑलवेज बी ऑन द राइट साइड if you are moving westerly, that means the destination will always be on the left side. Now the directions do not change beta. Whenever you make a diagram like this, the right side of the diagram always represent easterly direction. Whether you are looking at the earth from the Greenwich meridian side or you look at the earth from 180-degree meridian side, in both the cases, when you look at a diagram, the right side of the diagram always shows easterly direction and the left side of the diagram shows the westerly direction. It is something similar to a Mercator chart. On a Mercator chart, always on the right hand side you have the easterly direction.
okay, sir.
Okay beta, is it clear?
Yes, sir, clear.
ओके और बताओ बेटा और कोई डाउट्स हैं अभी तक Okay, very good. So let's proceed ahead then. We will see, we have now seen the known parts in this particular triangle. We have two sides and an included angle known to us. So we can apply the cosine formula. It fulfills the criteria where cosine formula can be applied. So let's apply it and solve. So you can see here this angle P is equal to the D long between A and B. So we now know that this triangle PAB is a spherical triangle, and two sides and an included angle in this triangle is known to us. So we can apply the cosine formula. Let's apply the cosine formula for angle P. So cos of any angle is equal to cos of opposite side minus cos of adjacent side 1 multiplied by cos of adjacent side 2 whole divided by sine of adjacent side 1 multiplied by sine of adjacent side 2. Applied for angle P, it gives us cos of P is equal to cos of AB, AB is the opposite side, minus cos of PA, PA is the adjacent side, multiplied by cos of PB, PB is the second adjacent side, whole divided by sine of PA multiplied by sine of PB. So if you look carefully in this formula, we know what is angle P. It is the D long between A and B, both the longitudes being available to us. The D long is known. PA is known to us. We have just now seen Papa Alpha is the colat of our position A. PB is known to us. It is the colat of position B. Again, in the numerator, Papa Alpha and Papa Bravo both are known to us. So all these are marked in green, indicating that all these values are known to us. The only unknown in this equation is side AB. That's why it is marked in red. So we put these values in the formula and we can easily calculate the value of side AB. Beta, the application of cosine formula is clear now. Any doubts up to here?
Clear, sir.
Very good. Once AB is known to us, it's a single step calculation in the scientific calculator. Once AB is known to us, we can easily find out what is the great circle distance between these two positions. AB gives you the great circle distance. Now, one very important thing to understand here is that when we apply the cosine formula, we are going to get this side AB in degrees, minutes, and seconds or decimal of a minute. Now, to calculate the distance, how do we convert this side AB into the great circle distance? Now, fortunately, 1 minute of arc of a great circle on the surface of Earth is equal to 1 nautical mile. So this side AB converted into minutes gives us the great circle distance. So from the calculator, when you apply the cosine formula, the calculator is going to give you the value of AB in degrees and minutes or decimal of a minute. We have to convert it into whole minutes. So very easy to do that. Whatever number of degrees is there in the answer, multiply it by 60. It gives you the number of minutes. Add the number of minutes along with the degrees, and you get the side AB in minutes. This side AB converted into minutes gives you the great circle distance between A and B in nautical miles. Whenever you are doing any calculations on this triangle, during calculation, the side AB is always used in the degree and minute format. But when you want to write your answers for great circle distance, it is not written in degree and minute format. It is converted to minutes and then written because 1 minute is equal to 1 nautical mile. So this gives us the answer to the first part of the question. What is the great circle distance between A and B? So you see, it's very, very simple. It's a single application of the cosine formula. So any doubts up to here, beta?
No, sir.
Very good. Okay, let's move ahead then. Now, having found the great circle distance between our starting and destination position, we come to the second part of the question now. The second part requires us to find out the initial and final courses. Now, to find the initial and final courses, we need to calculate angle A and angle B of the spherical triangle PAB. So we have this PAB triangle, a spherical triangle. We have already found the missing side, the unknown side of this particular triangle. That was side AB. Two sides were already known to us. Papa Alpha, which is the colat of A, Papa Bravo, which is the colat of destination position B, and the third side has been found in our previous calculation, that is side AB, which is the great circle track or the great circle distance between our initial and final position. With all the three sides known to us now, again we can use the cosine formula to find any angle of this triangle. So we will use this formula to find out angle A and angle B of our spherical triangle. So let's apply the cosine formula to angle A. Cos of angle A is equal to cos of PB. You see PB is the opposite side to angle A, minus cos of PA. PA is the adjacent side to angle A, into cos of AB. AB is the adjacent side again to angle A, whole divided by sine of PA into sine of AB. So you see we have applied the cosine formula once again, this time to angle A, and you can see in this formula all the items on the right hand side which are marked in green are already known to us. We know PB, we know PA, and we know AB also. Again, reminder to you, the AB side which we are going to use here will be the value of AB in degrees and minutes. We converted into whole minutes to find out the great circle distance, but whenever we use side AB for any calculations, we do not use the minutes format, we use the degree minute format. So once the formula is applied, the angle A can be easily obtained. So once angle A is obtained, we move on to angle B now. Angle B is similarly calculated by applying the cosine formula again. Let's apply the cosine formula for angle B. Cosine formula will now say cos of B is equal to cos of PA. You can see PA is the opposite side to angle B, minus cos of PB. PB is the adjacent side, multiplied by cos of AB. AB is the second adjacent side to angle B, whole divided by sine of PB into sine of AB. Again, you can see all the items on the right hand side marked in green are known to us. The only unknown here in this equation is angle B. So putting all these values in the equation, we can easily calculate the angle B value. It's a single step calculation in the scientific calculator. So remember these formulas. They are simple applications of the cosine formula. If you know the cosine formula, you don't need to memorize them. It is just a application to whichever angle we require. So once the cosine formula is applied here in this way, both these angles, angle A and angle B, are known to us. Now, how do we obtain the initial and final courses from these two angles? Beta, everything is clear up to here. Any doubts in the mind?
नहीं सर, अभी ठीक है सर.
Okay, all right. So let's see now, how do we get the courses? Let's see. Now, the first important thing to understand here is that just now what we have found are the angles of the spherical triangle PAB, angle A and angle B. Now, these are not our initial and final courses, but these angles are going to help us find what our initial and final course will be. In some cases, you will see numerically angle could be equal to the initial or final course, but in another case, they could be different also. So always remember, this should be clear in the mind that what we have found using the cosine formula are the angles of the triangle, and we need to use these angles to find out our initial and final courses. Now, the method which we are going to use here gives us the courses in 3-figure notation, or 360-degree notation, or true notation. We also use quadrantal notation for denoting the courses, but with this technique, we are not going to get the courses in the quadrantal notation. We will get them in 3-figure notation. Now, the course of the ship in 3-figure notation is basically the angle between true north and the ship's head measured clockwise. The angle is measured with reference to true north. We measure the angle in the clockwise direction, and we measure it up to the ship's head. This is the definition of the course in 3-figure notation. The angle is measured from 000 to 360 in the clockwise direction. So let us now see how these angles, angle A and angle B, are going to give us the initial and final courses. So for this, we need to make a rough diagram of the ship at our starting position A and the destination position B. So a rough diagram of the ship at both these locations. Let me make the PAB triangle here also. We don't need to show the full earth diagram now. We can now concentrate only on the PAB triangle part of it. So you see the North Pole, you see the initial position A, and you see the final position B. AB is the great circle track between these two positions. Let's first make a rough diagram of the ship at position A when it is moving on this great circle track. And let's make the rough diagram of the ship at our destination position B. So we have the rough diagram at both these locations visible now. Now, for finding the initial and final courses, follow a simple 1, 2, 3 stepwise procedure. Follow this 1, 2, 3 method and measure the course as an angle. What is this 1, 2, 3 method? Number 1, identify and start from north. Let's go to our initial position A. Now, at this position, which is the northerly direction? That is the first thing which we need to identify. We are aware, we know that the meridian run in north-south direction. Towards the North Pole, the direction of the meridian gives us north direction, and towards the South Pole, the meridian shows us the 180 or southerly direction. So to identify the north direction, we basically have to see where is the meridian going. Now, when the ship is at point A, the meridian is this green color track, which is taking us to the North Pole. So let's mark it as point N. So this N represents the direction of the true north. Similarly, when the ship is at its destination position B, again, we have to identify the north direction. So let's identify the meridian. The direction, the meridian is represented by this blue color track going to the North Pole. So this is where the north direction is. Let's again mark it with the N, showing that, representing that this is the northerly direction. Beta, step 1 is clear. You can mark the north direction from the meridian.
मतलब सर कहीं पे भी
Yes, sir.
केवल नॉर्थ डायरेक्शन देखना है.
That's right, बेटा. जहां पे भी शिप है हमारे इनिशियल पोजीशन पे और फाइनल पोजीशन पे, हमें देखना है कि उस पॉइंट से नॉर्थ डायरेक्शन कहाँ है. So we have to
Okay, sir.
identify the north direction.
Okay, sir.
Okay, beta. Any more doubt?
No, sir.
Okay, very good. So this is step number 1. Identify and start from north. Now moving on to step number 2. We have to go clockwise from here. That is from the north direction. We have to go clockwise. And in step number 3, we have to go up to the ship's head. So starting from north, let's come to our initial position A first. Starting from north, I move in the clockwise direction represented by this light blue color arrow. So starting from north, going clockwise, I go up to the ship's head. Now this angle basically gives me my initial course. Following this procedure at the destination position also, starting from north, going clockwise, I go up to the ship's head. So this is marked by this light blue color arc and arrow. So again, we followed the 1, 2, 3 procedure. 1 is identify north, 2 is go clockwise, 3 is go up to the ship's head. So this arc which we see here gives us the final course. Now you can see here in this diagram that our initial course is equal to angle A of the PAB triangle. So fortunately in this case, whatever angle A we obtained by using the cosine formula, same angle converted into 3-figure notation gives us the initial course of the ship on the great circle track from A to B. Now let's go to the destination position. Now at destination position, this is not the case. The angle B, which we have obtained using the cosine formula, is the inner angle of the triangle PAB. Inner angle. But our course is not the inner angle of the triangle. Our course in this case is the outer angle B of the triangle. So you can see here that the angle B calculated using the cosine formula will be a different value, whereas the final course of the ship at the destination position will be a different value. we can use the angle B to find out our final course. How can we do that? Now, just as a straight line, if you pick up any point on a straight line and you measure the angle of that straight line, it will always come to 180 degrees. 180 degrees is also known as a straight angle. So at any point of a line, if you measure the angle, it will be 180 degrees. Now this stands true in case of a great circle track also. So if you are at point B and you measure the angle from direction of A up to the direction in which the ship is heading, this total angle will be 180 degrees. This total angle being 180 degrees, we know the inner angle B. So 180 minus the inner angle B gives us the outer angle B. The outer angle B is what we require. Outer angle B is our final course. So 180 minus the angle B calculated using cosine formula gives us the final course of the ship.
Sir,
go ahead beta.
सर इसे ऐसे भी 180 माइनस एंगल बी कर सकते हैं जैसे हमने एंगल बी कैलकुलेट किया सर एंड द ऑपोजिट ऑफ बी इज आल्सो नोन टू अस एंड द मेरिडियन इज 180 degrees quadrantally it is 180 degree minus angle b it will again give us the true course. It will
Yes,
be also
beta.
like that.
Yes, what you are saying is right. You can think it in that fashion also, whatever is convenient to you. Opposite angles as you said are equal here. जैसे straight line intersection में opposite angles same होते हैं, उसी तरह से great circle intersection में भी opposite angles same होते हैं. So whatever is this internal angle B, it will be same as this angle on the outer side. And you know meridians, at any point on the meridian, if you measure this total angle, it will be 180. So again from that it comes to 180 minus B. जैसा भी आपको ये सोचने में convenient लगे, आप उस तरीके से सोच के आंसर निकाल सकते हो. It will be the same.
ठीक है सर, थैंक यू.
ओके, और बताओ बेटा, और क्या डाउट्स हैं?
सर इसमें ये एंगल भी बाहर से दिया हुआ है बड़ा भी, जिसमें ब्लू एरो बना हुआ है. दैट इज सपोज्ड टू बी द फाइनल कोर्स, राइट?
राइट बेटा, जो फाइनल कोर्स होता है, द डेफिनेशन ऑफ द कोर्स इज angle between true north and ship's head measured in a clockwise direction. So you can see जो ये हमने light blue color के arrow के साथ angle show किया है, it is exactly that angle between true north and the ship's head measured in a clockwise direction.
Yes sir, but सर ये नीचे लिखा हुआ है फाइनल कोर्स इज इक्वल टू 180 डिग्रीज माइनस एंगल बी, बट यहाँ पे तो सर ये यही भी हमारा रहेगा ना. माइनस भी तो हमें से अंदर ट्रायंगल के अंदर वाला एंगल देगा ना बी का.
Yeah, the meaning of 180 minus b, जो बेटा यहाँ पे मैंने 180 minus b लिखा है ना, this is the inner angle of the triangle जो हमने cosine formula से calculate किया था.
ओके सर, ठीक है. वो मतलब मैं ये सोचा था बाहर भी लिखा हुआ है बी और नीचे पे भी लिखा हुआ है, ठीक है. दैट इज द इनर. या अंडरस्टूड.
Okay, so this b is basically the point in the diagram which we named as b, and this b written here represent the angle b calculated by the cosine formula from the PAB triangle. Okay, और बताओ बेटा, और क्या डाउट्स हैं अभी तक?
On a westerly course, the procedure is slightly different here. So in our initial example, we had considered a ship moving in the easterly direction in the northern hemisphere. Now let's consider a ship which is moving on a westerly course and see how does this process helps us to find out the initial and final courses. Let's make a rough diagram first. You can see the pole here at point P. Our initial position is at A. You can see point A here. And the final position is at Bravo. You can see the point B on the screen now. So let's make the PAB triangle. We have the blue color side, the Papa Alpha side. We have the second side, Papa Bravo side of our spherical triangle PAB. And you can now see the third side representing the great circle track between A and B. The arrow shows the direction of the track. Vessel is moving from A to B. So with the rough diagram now made, showing the starting position, the destination position, and the pole, let's now follow our stepwise procedure. Step 1 says we have to draw the rough diagram of the ship on the starting position as well as the final position. So you can see a rough diagram of the ship being made at A. Let's make the rough diagram of the ship at point B also. Now we are going to follow the 1, 2, 3 method. Step 1 is to identify and start from north. So as discussed earlier, the direction of the meridian going towards the North Pole gives us the northerly direction at any particular point. So at A, the direction of the meridian going towards the North Pole gives us the northerly direction. So let's mark it as N. And at point B, the direction of the meridian going towards the North Pole gives us the northerly direction here. Now the second step is from this northerly direction, we go clockwise and we go up to the ship's head. So at our position A, starting from the northerly direction, moving in the clockwise direction, I go up to my ship's head. So this light blue color arc and arrow shows us the initial course of the ship. Now from the cosine formula, we are able to find out the internal angle of this triangle, that is this angle A. But for the course, for the initial course, the angle which we need to find is this complete outer angle. So how do we find this outer angle from here? The total
360
angle
minus A.
from north going clockwise and coming back to north is 360 degrees. Just as it is with straight lines, you start measuring the angle at any point on the straight line, going clockwise, coming back to that line, it gives you 360 degree angle. So this complete angle starting from N, going clockwise up to N is 360 degrees. The internal angle A is known to us. So our initial course in this case will be 360 minus angle A. So you can see it here. The initial course in this case is going to be 360 minus A. Let's come to the destination position now. We have identified the northerly direction. Let's go clockwise from the northerly direction and go up to the ship's head. So this light blue arc and arrow gives us the final course of the ship. Now again, looking at this diagram, what we know from the cosine formula is this internal angle B. What we now require for our final course is the angle represented by the light blue arc going up to the ship's ahead. So how do we find it? Now for this, the
180
first
plus
thing to understand is that just like straight lines, when two great circles intersect on the surface of a sphere, the opposite angles are the same. So if this internal angle Bravo, which was found using the cosine formula, is known to us, we know that its opposite angle, that is this one, will also be of exactly same value. So this opposite angle is equal to angle B, and we also know that from the north direction to the south direction, that means up to here, meridian to meridian, this is a straight angle, that is 180 degrees angle. So this now tells us that our final course is going to be 180 plus angle B. So you can see here, the final course will be 180 degrees plus angle B. So you can see now how knowing the initial and final angles, angle A and angle B, helps us to calculate the initial and final courses. In this case, none of the angles was equal to the course. So we had to use the diagram and the 1, 2, 3 method to find out what is our initial and final course.
This is also clear, beta, up to here. Any doubt, query in your mind, please share.
No, sir.
Okay, very good. So let's proceed ahead now, see some more cases.
Now we have seen the courses being found in the northern hemisphere with a ship moving in the easterly direction in one case and moving in the westerly direction in the second case. Now let's try to see this and let's try to see how does the method work when the ship is in southern hemisphere. In the southern hemisphere, let's consider a westerly course and try to make it as complicated as possible. So let's first make a rough diagram of the PAB triangle and then the diagram of the ship at the initial and final positions. So in this case, we are in the southern hemisphere. So I take the south pole at point P here. Our starting position is at A and the destination position is at B. The meridian of A is drawn now. Papa Alpha PA, you can see the blue color line. The meridian of point B is also drawn. And let's now join point A and B with the great circle track. So in red color, you see the great circle track from A to B. The direction of the arrow shows the direction in which the ship will be proceeding. So we have to first make a rough diagram of the ship at our starting position A. We have it on the screen now, and we have to make the rough diagram at our destination position B. This is how the ship will be proceeding on the great circle track. Now we will first calculate angle A and angle B. That is these angles of the triangle BAB, angle A and angle B, using the cosine formula. And once these angles are known, we can use these angles to find out our initial and final courses. So let's now apply our 1, 2, 3 method and see how we can identify the course at each location. So first of all, we have to identify and start from north The direction of the meridian going towards the North Pole gives us the northerly direction. So at point A, meridian going in this direction towards the North Pole gives us the northerly direction. I have marked it with the end point here representing true north. And if you come to the destination location, the direction of the meridian going towards the North Pole represents the true north. So true north represented by N at both the locations. Now we have to go clockwise from this direction north, and we have to go up to the ship's head. So at our starting position A, starting from the north direction, going clockwise, going up to the ship's head, represented by light blue arc and arrow. So this arc and arrow shows the ship's initial course. Now how to obtain this course from our angle A? You see, angle A is the internal angle of triangle PAB, this particular angle. We know from north direction to south direction up to here, this angle is 180 degrees. So the initial course is given by 180 up to here plus angle A. So initial course is given in this case as 180 plus A. That is the initial course calculation. Let's go to the destination position now. Again, we follow the 1, 2, 3 method. Starting from true north, going clockwise, going up to the ship's head, represented by the blue, light blue color arc as well as arrow. So what we know now is the internal angle B, that is this particular angle, but we want to know the angle represented by this arc.
So can you tell beta what will be the final course in this case?
360 minus B, sir.
Very good. That will be 360 minus B. Let's see how.
So how do we do that? If we know the internal angle B of the PAB triangle, I know opposite angles are equal. So this tells me that the outer angle B, this one being shown on the screen, will be equal to angle B of the PAB triangle. Now, once I know this angle B, the required angle for me would be 360 minus angle B. So 360 minus angle B gives me my required angle. The final course is thus given by 360 minus B. So we have done these calculations, the courses calculation in the northern hemisphere as well as in the southern hemisphere, with the ship moving in an easterly direction as well as in a westerly direction. Now always remember that this method gives us the courses in the 3-figure notation or true notation. If by any chance you need to find the courses in quadrantal notation, the method will not straight away give it to you. You first calculate the courses in the 3-figure notation and then convert it into quadrantal notation. We are very familiar with the process of converting true to quadrantal or quadrantal to true. So that's hardly half a minute job for us. So first you calculate the courses using 3-figure notation using this 1, 2, 3 method. And once 3-figure notation courses are obtained, they can be converted to quadrantal if required by the paper setter. So this basically takes care of a basic great circle sailing problem. That is, given the latitude and longitude of our initial and final positions, how to find out the great circle distance between them, and how to find out the initial and final courses. We have only used cosine formula. That is the only formula which is used here. So the procedure is very simple. It is a simple application of the cosine formula.
Beta, any doubt in your mind?
No, sir.
Okay, very good. So now what we are going to do is I'm going to give you one question right now. In fact, that is there in the assignment. What I'll do is, beta, I will send you your first assignment now. Okay, before we go into the assignment, one more thing which I would like to emphasize here. When you do these calculation, it is very important that the PAB triangle which you are making, that should be correct. Now, what do I mean by correct? Now, when you see the two positions which are given, their latitude and longitudes are given to us. You should be able to find out in which direction the ship is proceeding. Like this particular PAB triangle which you see on the screen right now, our ship is moving in the southwesterly direction. So we are able to judge this by the latitude and longitude of the initial and final positions. So by mistake, if you are not able to draw this diagram correctly, instead of westerly, if you show a easterly course here and you apply the cosine formula, then in that case, the answers which you will be getting will be wrong. So it is important that the direction in which the ship is proceeding is judged from the initial and final positions. Normally latitude में कोई doubt नहीं होता है. Latitude makes it quite clear whether you are going towards north or south, but sometimes the doubt comes in the longitude, especially if you are crossing the international date line. So you should know very clearly what is the direction of the D long. Now, if you are unfamiliar about finding the direction of the D long, this was done during second mates as well as pre-C. But if you still feel that it needs a little brushing up, then I would recommend बेटा जो हमारी practical navigation की book है, उसमें जो हमारा I think second या third chapter है, it gives basic calculation of DLAT and D long. So just go to that chapter and have a look at the calculation of D long. Your doubts will be sorted out. If any doubt still remains, let me know and I'll clarify those doubts. So अगर आपको D long की direction निकालने में confusion होता है, तो एक बार बेटा उस chapter को देख लेना है आपने, and then you can come and do these numerical based on great circle sailing.